Now let's continue to study the arc length in polar coordinate. So firstly, let's take a review what is arc length for the parametric equation. I think we did that in 10.1 review. So parametric equation means x equals xt, y equals yt, and the arc length equals integral of dx dt squared plus dy dt squared and dt. And t is the parameter, right? So that's the formula. And right now we have our r is f theta. So we have the similar thing. We have x equals r cosine theta. So which is f theta cosine theta. And y equals r sine theta, which is f theta sine theta. This is similar to the tangent of the polar curve, right? So when we find the tangent, we do the same way. And now we just do, so let's see what's the parameter, theta. Now our arc length equals what? So let's take a look. dx d theta equals what? And the dy d theta equals what? dx d theta, which is f prime cosine theta minus f sine theta. And the derivative y respect to theta, which is f prime sine theta plus f theta cosine theta. Right now we just do dx over d theta squared plus dy d theta squared, which is just like. Now we are going to change f prime into r prime. Okay, so it's like minus r sine theta square r prime sine theta plus r cosine theta square. So actually after we simplify, we can cancel a lot of things. So r prime cosine theta square plus r square sine square theta minus 2r prime sine theta cosine theta, and then plus r prime square sine theta square plus r square cosine square theta, and plus 2r prime sine theta cosine theta. And then we notice that those two terms are totally the same, and one negative, one positive, we cancel them. And if we look at this term, we combine those two, and the sine square plus cosine square equals 1. So this gives us r prime square. And if we add those two terms together, same thing, this gives us r square. Okay? So in this case, our arc length equals what? Theta from alpha to beta, and the square root of dx over d theta square plus dy d theta square, which is just r prime square, so which is dr d theta square plus r square. So that's the formula for the arc length. Now let's take a look at the example. You can also write down, remember this as alpha to theta r square plus r prime square. Either way, okay? They're the same thing. Example 3. Find the arc length of cardioid 1 minus cosine theta. So this one, same thing. Theta is from, I think the graph looks like this. Okay, theta from 0 to 2 pi. If we want to find the whole arc length, we are going to set up this 0 to 2 pi and I'm going to write down the formula firstly and then do the calculation. So r squared is 1 minus cosine squared, and dr d theta. dr d theta cosine derivative should be sine squared d theta. Now simplify. 1 minus cosine 2 theta. Okay, and then plus cosine squared plus sine squared. Zero to 2 pi. Here, this equals 1. Is that right? So what? 2 minus 2 cosine theta d theta. So this is similar to our quiz 4. Here, we factor 2 out, 1 minus cosine theta d theta. Same thing, we want to use the double angle formula. We want to take off the square root. With the square root, we cannot, integral this function. So we are going to use this. 1 minus cosine theta equals 2 times sine square theta over 2. This formula. Okay? So in the quiz, we had this thing. 2 cosine square theta over 2. Is that right? Let's see. 0 to 2 pi. 2 times 2 sine square theta over 2 d theta. And the 2 and the 2 can take out the square root, which is also 2, and the sine theta over 2. 0 to 2 pi d theta. Let's see. This equals 2 times integrals cosine theta over 2, actually negative, right? Negative. And divide by 1/2. And cosine theta from 0 to 2 pi. Let's just simplify this thing. Okay. Now this equals what? It's negative 4 in front, and cosine pi minus cosine 0. Cosine pi is negative 1 minus 1, so give us negative 2. Right, negative 2 times negative 4, which is 8. So the final answer should be 8. If you want to try another exercise, here is a good one. Find the arc length for this. Okay. Because we have, for arc length, we always have square root thing. So for the square root, if we want to take off the square root, we will always have the double angle formula. So please be very familiar with the double angle formula. You can try this one. I'm going to give you another exercise. One loop of 4-leaf rose. I give you the second exercise problem because I want you to see how to find the boundaries for theta. This is cosine 2 theta, okay? R equals cosine 2 theta. And the graph of this 4-leaf rose look like this. So here is one loop, one, and another one. Okay. So find one loop of the 4-leaf rose, one loop. So you can choose either one. You can choose, we say 1, 2, 3, 4. You can choose just the loop 1. Okay. But I'm not going to find the whole loop. I'm going to do here. Going to just find this arc length of this one. So I just want to find the half of the one loop and then double it. So firstly, we need to find, the most important part is we need to find the angle here. So for the angle, we don't know what's that. Okay, so what is theta? I'm going to do this way. So L equals 2, 0 to this angle. Okay, and then square root r squared plus r prime squared d theta. So the most important part is what is the theta, right? Okay. Or you can just do negative that angle to that angle and don't times 2. So here I just multiply by 2. Let's see. How do you find that angle? We're going to do this way. At origin, you can see r equals 0. Is that right? At origin, if you look at my pen, at origin, r equals 0. So we make r equals 0, which is cosine 2 theta equals 0, and solve for theta. Okay, and that means what? 2 theta equals cosine what is 0? Pi over 2. That means theta is pi over 4. So in this case, we can find our theta is pi over 4. It looks like a pi over 4, right? So our integral becomes what? L equals 2, 0 pi over 4, and r squared, which is cosine squared 2 theta, plus the real cosine should be 2 sine squared 2 theta. And when we square it, 4 sine squared 2 theta. Okay, so for this one, it's pretty difficult to evaluate. You can just stop here. Just set up the integral. Let's have a quick review of the area. Okay. If we want to find the area, what's the formula? 1/2 r squared d theta, alpha to beta, right? That's the formula. And for this case, we can do the same thing. Double of the area from 0 to pi over 4. And what is r squared? Cosine squared 2 theta d theta. Okay, so for the area is interesting. We always have square thing. Is that right? We always have something square, and we always need to decrease the power. We also use the double angle formula. It's just opposite way with the arc length. Arc length, we need to increase the power, take off the square root. Here, we need to decrease the power. For the area, we always has square. Okay, so cosine square 2 theta. I'm going to give you the original formula, which is cosine square theta is 1 plus cosine 2 theta over 2. Is that correct? Okay. But right now, in our problem, we have 2 theta. So it's called double angle formula, which is double the 2 theta angle. So it becomes 4 theta over 2. Double angle of 2 theta, which is 4 theta. So let's see. 2 times, sorry, I forgot the 1/2 here, right? So cancel the 1, 2 and 1/2. And the cosine squared 2 theta d theta, just copy it. Let's do one more step. Okay, 1 plus cosine 4 theta d theta, so which is 1/2. Evaluate that one. 0 pi over 4, which is 1/2 theta plus sine 4 theta over 4 from 0 to pi over 4. And sine pi, sine 0, both are 0. So we just make this term, ignore that term. So the final answer just 1/2 times 4 pi over 4, which is pi over 8. That's the final answer. Okay. So in this exercise problem, there are 2 things need to pay attention. First one, how to find theta. Okay. And the second thing is when we evaluate the arc length, we need to increase the power, take off the square root, double angle formula. For the area, we always have square, so we need to decrease the power. Same thing, double angle formula. So in this section, we have to be very familiar with those formulas. And if you want to do more exercise, let's try 1 minus cosine 6 theta equals what? Okay. Increase the power. And here, sine square 4 theta equals what? So this should be 2 sine square something, right? And half of that, 3 theta. And this one should be 1 minus cosine double of 4 theta, so it should be 8 theta over 2. Just play with, the formula. So in this section, we just need to know area and arc length. And for the formula, I think it will be given. Okay, you don't need to memorize. We can stop here.